Question 4. The force F newtons on an object is equal to its mass m multiplied by its acceleration a in meters per second squared. There's a typo here, so that should be meters per second squared. That meant meter over second squared. That's the unit for acceleration. But it also said that acceleration can be calculated by the difference between its initial speed u and the final speed v divided by the time taken t. So question A, we need to write the formula for force, which is already stated up here. So we're just repeating that. So that would be F equals mass times acceleration A, and that equals F equals ma. So that's the force. And B part states that the acceleration A will be equal to final velocity minus initial velocity over time taken. So that's the B part. And the C part is saying that an object of mass 5 kilograms start moving at a velocity of 3 meters per second. So that's the velocity. After 6 seconds, it is moving at a velocity of 15 meters per second. What is the acceleration? So part 1. So C, part 1, is A equals V, the final velocity, because the initial velocity was 3 meters per second, and the final velocity was 15. So that will be 15 minus 3, the initial velocity. So final velocity is 15, and initial velocity is 3. So U is 3, and V is 15. And then we divide that by T, and the time was after 6 seconds. So that would be over 6. And that would be 12 over 6, which gives 2 meters per second squared. So that's the acceleration. Part 2, what is the size of the force acting on the object? We know the acceleration, so we know that A equals 2 meters per second squared. So that's the acceleration there. Now we need to work out the force acting on the object. So force equals mass times its acceleration A. And the mass of the object is 5 kilograms times 2, and that equals 10 kilograms meters per second squared, which equals 10 newtons. So the force required is 10 newtons.